Welcome everyone, and thank you for joining us for today's webinar, Meltdown and Spectre, Performance Impact and Mitigation Strategies. My name is Sarah Queen. I'm the Senior Marketing Manager for our Services Portfolio here at Citrix. In today's session, our team of architects will discuss these new security vulnerabilities, including how they work, key differences among the variants, and what they mean for your Citrix infrastructure. Before we go into the presentation, let me quickly review a few housekeeping details. We will have a live Q&A toward the end of today's event, and you're welcome to submit your questions during the presentation. Simply type your question into the Ask a Question window and click Submit. Also, we are recording this event, and the on-demand version will be available from the same link that you used to join today. So feel free to come back, watch the archive, or share it with your colleagues. And finally, the slides are available for download from the Event Resources tab located along the top of the interface. All right, let's go ahead and get started. I'll hand it over to Martin Zuchek, Senior Architect and Security Expert. Martin?
Thank you, Sarah, for introductions. We can start with talking about the agenda of today's webinar. We will start with a quick overview of these vulnerabilities, what they are, when they are originated from, what to expect from them from a more security perspective. Then Nick is going to talk about performance impact they have on the XenApp and XenDesktop workloads. Then we move to potential mitigations and tips and tricks how you can minimize this impact. And finally, we will talk about what's next. So let's start at the beginning, the overview of vulnerabilities. We are talking about a brand new class of security attacks that were announced in January 2018. What this new class of vulnerabilities are doing is that they are taking advantage of design flaw in computer processors that is called speculative execution side channel vulnerabilities. Unfortunately, at this moment, we don't have one summary name for all of them. But what is important to remember from this part is that it's not only Meltdown and Spectre, as they are known, but it's a brand new class that is going to stay with us for months or maybe for years. So this is not a one-time thing, and you can expect that we will see more of them in upcoming months. As I mentioned before, they are known as Meltdown and Spectre, even though in total we actually have 5 different variants that are present at this moment. We have 2 variants of the Meltdown, which melts the security boundary between the program and operating system. This effectively means that the user is able to read the code from the operating system that he shouldn't have access to. For example, read the passwords, credentials, certificates, and so on. The Spectre, at this moment, we have 3 different variants. This exploits the branch misprediction, which means it's largely invisible from normal programs. Traditional antivirus is definitely not going to help. And as I mentioned, we have 3 different variants. You probably saw before that we have 1 variant of Meltdown and 2 variants of Spectre. In February, 2 more variants were announced, the Meltdown Prime and Spectre Prime. The reason why we include them here is that it looks like that not all the mitigations are going to work against these new. So even though before they were kind of folded together to existing announcements, now with the new CPU core isolation and so on, we really need to separate and think about them as 2 additional variants. This is very important. Meltdown and Spectre, they were announced at the same time, but they are actually very different and require different approach, different mitigations, and they are going to have different impact. And this is one of the confusions that we are seeing in the field. So this was the announcement, but what actually it is from security perspective. What I like to say is, think about it this way. Modern operating systems and all the applications depend on software security models that are isolating the code on a device, whether it's virtualization or hypervisor-based isolation, kernel user separation, or process-based separation or isolation. Now, all these security designs have dependency on the underlying hardware. And unfortunately, with the speculative execution side channel, we break all these security models at once. To think about good analogy, it's like you are building your castle with all the defenses, and at the end you realize that you build it on the jello instead of building it on the solid ground. So new class of vulnerabilities that has impact on everything we do, on hypervisors, operating systems, all the different operating systems, various devices, and so on and so forth. The way how these vulnerabilities operates is they kind of go through three different stages. First one is the priming stage, where effectively the cache is being wiped out or emptied. Second stage is triggering phase, where this code is going to force the CPU to load some code in the cache, even though we don't have access to it. And last one is observing phase, where we determine what's the content of the cache just by observing the system. So this is pretty much what side channel attack stands for, is that we are looking at the physical implementation to retrieve the data. Side channel attacks typically look at the power consumption, temperature, and so on. In this case, we are specifically using the CPU cache. So what's so unique about these vulnerabilities? First, they are hardware-based attacks. So these vulnerabilities exist in the hardware or the chip, which means it's very difficult, and maybe even impossible in some cases, to fix this with a simple software patch. At first, what we saw is that we were relying on the hardware vendors or the system vendors to release the firmware patches. This is changing now, where we're seeing Microsoft is releasing the microcode updates as a software implementation in Windows. Some even argue that the true root cause cannot be fixed with microcode, and we really need new chips. And these new chips were actually already announced by Intel a couple of days ago, but we don't know yet exactly how they are going to fix it, what's going to be performance impact. So it's important to understand that the Meltdown and Spectre and all the other potential vulnerabilities, the situation is still very, very fluid and keeps developing. Almost every week we see some new information. What's also important to understand for the hardware-based attack is that all the different devices and operating systems are vulnerable. So it's not only, for example, Linux problem, it's Windows, Linux, macOS, Chrome OS, all of them. You probably saw some news about all the different IoT devices being vulnerable as well. Important thing to mention here is that both Meltdown and Spectre requires the ability to execute the code. So they don't allow you to execute the code, you need to do it on your own. So many of these devices, while theoretically vulnerable, first you need to find out how to execute the code on them, which makes them much more secure in this perspective. Second important and unique characteristic here is that Meltdown and Spectre are invisible. They are happening on a very low level, and they are extracting the data by looking at the cache behavior. So they just compare the timing. So trying to detect them, it's using traditional tool, it's almost impossible at this moment. Finally, one of the unique characteristics is that there is performance impact. So it's not only security, we are talking effectively about the impact on security, performance, budgets, and many other things. What we are doing with Meltdown and Spectre is that we are mitigating hardware vulnerability through the software patches, which is very expensive from performance perspective. It's more of a workaround because we cannot easily replace the physical chip. So there is potentially significant performance penalty, and it's going to depend on a lot of different variables, actually. Initial patches that were released were mostly focused on getting this fixed and haven't been optimized for performance. So the chances are that over the time we will see patches that perform better and where this performance impact is minimized. We understand and we can easily patch the Meltdown, but Spectre is much more complicated, and it's going to take a while until we will see what's going to be the final, let's say, combination of solutions. So if you see any initial performance numbers on the Spectre, you should not trust them, and you should, again, this situation is fluid and keeps developing, so you want to keep on track and watch what is the latest development here. So to quickly summarize the Meltdown and Spectre, here are the CVE numbers for all three different variants. The two additional variants, one more Meltdown and Spectre, doesn't have the CVE numbers yet, and we will see if they will be assigned. But as I mentioned before, it's good to think about them as different variants because mitigations are going to be different for them than for these three variants that you are seeing in front of you. Now, just a quick comparison, Meltdown and Spectre. So as I mentioned before, Meltdown, that's the one that we understand it much better than the Spectre at this moment. Initially, this was presented as Intel-only issue, but we know there are more processors that are being impacted by this. The ease of exploitation for Meltdown, it's pretty easy to use this code, but it's also easy to fix it. So from this perspective, Meltdown is probably priority for us, and what we are seeing today is that this is mostly fixed on the operating system level. So this is important. Meltdown does not require firmware updates, or it doesn't require microcode update. So if you are waiting for the finalized firmware before patching, that's required for Spectre, but nothing prevents you today from patching the Meltdown. The exploitation of Spectre is much harder, but also mitigation is much more complicated. As I said before, Meltdown is, we pretty much solve it on operating system level. For Spectre, you need to fix the hypervisors, you need to fix the underlying hardware, you need to have fixes on operating system level, you need to have new versions of compilers, you need to recompile all the applications, and you cannot do just one of those. So it's not only fixing the hypervisor is going to fix all of them, you need to apply patches across all these different layers. That's why it's a lot more complicated. From performance perspective, we have a lot of data about the Meltdown, but Spectre, as it keeps changing, we still don't know what's going to be the final verdict here. Talking about processors that are impacted, pretty much all the modern processors that are using speculative execution are potentially vulnerable to Spectre. And again, as I mentioned before, if you are waiting for the final version of the firmware before you start fixing all these issues, that's required only for Spectre and only for variant 2. Firmware upgrade is not required for Meltdown or Spectre variant 1. So what should be your key takeaways at this moment? Meltdown is fairly well understood. We know what it is, we know how it behaves, we know how to fix it, we know what's the impact, and it doesn't require the firmware upgrade. Spectre is much more complex and requires multiple different components to be patched, including the microcode. But here what is important is these vulnerabilities are very different and should be treated as such. Probably as this is new class of vulnerabilities, so it's not only Meltdown and Spectre, you want to keep a track of what's happening, you want to understand what are the implications, and you want to have ongoing process where you evaluate all these new vulnerabilities, what they mean for you, and have some processes in place how to solve them. And final note about the key takeaways, you can expect there's going to be some performance impact that's going to be very different based on the devices. And I would like to ask Nick to continue and talk about the causes of this performance impact and what you can expect to see on the XenUp and XenDesktop.
Perfect. Thanks, Martin. So my name is Nick Rentalen, and I'm our principal architect in our CCS, or Professional Services Group. I've been at Citrix the last 14 years, and scalability and security are two of my favorite topics. So this Meltdown Spectre stuff is right up my alley. And I have the privilege of talking about some of the early performance numbers we're seeing in the field on our consulting engagements, some of the stuff our partners have been doing, and some of the testing we've been doing internally, our engineering team at Citrix. But before we begin, I have to show the obligatory disclaimer slide. And this can pretty much be summed up as, it depends, or your mileage will vary. But yeah, big surprise, right? The typical consulting answer. But it's always been one of my pet peeves to hear, it depends. And then when I, question someone about that and say, that's fine, but what does it depend on? Or give me some ballparks. It's crickets, or that person can't tell me what it depends on. So today I'm going to share the 4 or 5 primary factors that Meltdown and Spectre performance is dependent on. And then we can talk about some of the numbers or the ranges we're seeing. And everyone will have hopefully a common understanding of why some of the numbers are on one end of the range or spectrum and others are on the other end of the range or spectrum. All right. So the first thing I think that's important to understand is the notion of transitions. And the reason transitions are important is because Meltdown and transitions don't mix, or they're not friends, might be another way to put it. And I feel like a lot of people out there assume that everything or most processing is done in the user space these days, and that's simply not true. We'll talk about legacy operating systems in a minute, but I encourage everyone to fire up good old perfmon and add both user time and privilege time. The more privilege time you see, or like red in the case on the slide here, the more transitions you can expect between user and kernel modes. And the worse the performance impact will be with the Meltdown mitigation in place. And that brings us to our first key factor or variable. It seems obvious to cite the app or workload, since we always do, but it's in a different context here. I want to be clear. Apps that are I/O intensive or syscall heavy, i.e. anything done in the kernel mode basically, will suffer more. These apps will cause more transitions and more of a performance penalty. Now, before we talk about the next few variables or factors it depends on, I want to take a step back and talk about some operating system concepts for a minute. I know this slide looks really scary, and it's going to require you to recall some of that knowledge from your college OS class probably, but hang in there. We'll try to get through this together. So you've all probably done the same homework I have and read up a bunch on Meltdown and Spectre in general, and you've probably seen terms out there like PTEs and TLB and PCID. But I don't see a lot of the resources explaining what these things are, or actually like how they're involved in a solution like kernel page table isolation. So starting from the top, I like this picture from Wikipedia actually on the right-hand side because it shows how we did things in a pre- and post-Meltdown or KPTI world. The net is we have dual page tables now. And in the post-Meltdown world, the user space only contains a small subset of the kernel space, as shown here in the picture. So we're effectively isolating some of the precious PTEs for security purposes. So now that you're kind of rock solid on the dual page table concepts and PTEs, let's talk about this translation look-aside buffer, the TLB. So the TLB it's a cache containing special or select PTEs that help us improve performance. That's what it's all about, and that's great. But the catch is we have to flush or delete the TLB every time the OS switches to a different set of PTEs. And since you now know we have dual page tables and everything is effectively separated out for security reasons, this means we're flushing that TLB a lot more, and performance will suffer as a result of Meltdown. But not to worry. PCID and invalidate PCID to the rescue. These are new CPU instructions, actually not quite new, I'll explain in a minute, but they're CPU instructions that were actually introduced several years ago, but nothing, as in a Windows operating system, ever really took advantage of it till now. And Meltdown finally gives us a reason to leverage these lurking CPU instructions. And what do these instructions do exactly? They give the TLB some smarts, is how I like to think about it. And the result is we don't have to flush the TLB when we switch to a different set of PTEs. This is huge when we're talking about Meltdown. And, in talking with our security team, they believe this might be one of the single biggest variables, when talking Meltdown performance. So double check if your hardware has these instructions using something like core info, and then away you go. And if you run core info with the -f flag, as shown here on the slide, and all you do is pipe it to a file, what you'll want to do is check for asterisks or stars next to PCID and invalidate PCID, and that means they're there or available. If you see dashes or minus signs, then that means the instructions are actually not there or available in that specific chipset. So that's kind of important. All right, on to the next 3 variables. So right after these vulnerabilities were announced in early January, Microsoft was one of the first to come out and publicly say that Meltdown is probably going to impact server OSs more than client OSs. So why is that? Well, a couple reasons that I point out on the slide here. First is server OSs are optimized more for background processes and simply do more stuff in the kernel space. And in a XenApp or RDSH multi-user world, there's a lot more chances, right, for transitions from user to kernel mode and back. So it makes sense why client OSs aren't impacted as much. The second thing there, in terms of the OS gen, it's kind of the same story. Windows 10 and 2016, they've moved a lot more code from the kernel to user space. So it's optimized in essence. And if you think about the old hardware these legacy platforms are running on, some of the really old OSs can't take advantage of PCID optimizations we just talked about. I was surprised to even find out that font rendering, yes, font rendering is done in kernel mode in Windows 7, 8, 2008 R2. And just think about how many times we're doing that in the XenApp world. And then last but not least, the CPU or chipset gen. And luckily you already know about this since I just painfully covered it. But a couple other notes to add here maybe. PCID and invalidate PCID, they were actually not introduced at exactly the same time. I've already come across a specific chip that has PCID and not invalidate PCID. I believe PCID was introduced with Intel's Westmere architecture, and then invalidate PCID was introduced with Haswell. And the other catch, if you don't have both, then Windows won't use either when you enable the Meltdown mitigation. So definitely beware and double check your hardware with core info, as I mentioned, and then be confident that your TLB's got those smarts with these new CPU instructions, and they can take advantage of them. All right, so now that you understand kind of those 4 or 5 factors or what it depends on, let's get to the good stuff here and talk about maybe the best case and worst case examples. I came up with this slide to try and make it really easy. So you probably all seen the ranges online of 5 to 30%. When it initially all these vulnerabilities surfaced in January, or maybe you've seen now 7 to 40%. Or whatever. So what makes it 5 or 7%, and then what makes it slide toward that 30 or 40%? So I submit to you the best and worst case scenarios or examples. So the best might be something like Zen Desktop, versus XenApp, a newer version like 7.15 versus an older version, and then with Windows 10, so a newer OS, and then running on the latest hardware. And then with a minimal set of applications running primarily user space. So very friendly, newly written applications maybe that don't have a lot of transitions, right? If you remember back to what we were talking about there. So it's a client OS, and we're also taking advantage of those CPU instructions. And then the worst case, well, just flip everything on its head, right? So now we have a server OS or XenApp, an older version, 6.5, or maybe like LTSR1, like 7.6.3. Older Microsoft, operating system like a 2008 R2 or 2012 R2, which is really common right now, I might add, in the field. And then, running on maybe 3-4-year-old hardware with a variety of applications and frequent transitions from user to kernel mode and back again. And that's just to mention, again, a server operating system as opposed to a client OS, and maybe we don't have those instructions or just have one, and then it won't use either. So that's where you're going to see probably the worst case scenario and some of those numbers that might be out there, right? On the blogosphere in the 30% range. All right. So now let's dive into some of the initial Meltdown results and talk a bit about Spectre, since the jury's still largely out, as Martin was saying. But a few of our partners have done some good testing in this area and analyzed Meltdown only very well. So let's talk Meltdown only just for a minute. And most are reporting low single digits, which is good. Others have seen some higher numbers. To give you a little more context, let's spend a minute talking about LogMVSI's results in particular. I'm a big fan of LogMVSI, in case you don't know. When looking at Windows 7, the performance hit was found to be around 11 to 14%. And then on Windows 10, it was more like 3 to 6%. So you can see right there how much of a difference things like transitions and PCID make. And also note the optimized images allow you to reduce the performance impact by 3% or so. And that's nothing to ignore for sure. And the last thing I'll say about Meltdown is we have some testing underway at Citrix, and we're not seeing a huge impact in terms of performance with Meltdown only. Spectre, however, is a different animal, and so let's talk about that one a little bit. All right, so first thing when it comes to Spectre, the microcode has only been re-released very recently, so within the last couple of weeks is all. So this is still very fresh, and a lot of the original Meltdown and Spectre numbers so the joint numbers what you saw together, like in the January-February timeframe, you can probably really ignore and forget about, as Martin said. But we finally got our hands on some of the updated microcode and started doing some testing in-house. And remember, there's 2 variants with Spectre. And while we're not ready to share official numbers, it does look like the impact of the Spectre mitigations are going to be more significant compared to Meltdown. But it's still early days, and we expect many more patches, and then optimized patches, and then new patches and microcode, et cetera. And then later this year, we expect new chips with things like virtual fences from Intel and probably a lot of other stuff we don't even know about yet, to be honest. So stay tuned, and we'll continue our internal testing and share more numbers as we can. And before I turn it back over to Martin, I want to cover one last thing since I've been getting a lot of questions about it. It kind of goes like this. Hey, Nick, I've been using that rule of 5 and 10 to estimate single server scalability. And in light of all this, security stuff, how does that change? And I usually say, great question. There's good and bad news, though. The good news is we've actually been inching up to, the magic multipliers of 6 and 11 or 12, sometimes even 7 and 14 on the latest gold chips, for example. But the bad news is in light of Meltdown and Spectre, we're heading back to 5 and 10. And in some of those worst-case scenarios, older hardware, older platforms, et cetera, it might even drop below 5 and 10 to, say, 4 and 8 or 9. But overall, the rule of 5 and 10 still applies, and you can still use it to quickly estimate, triple S or single-server scalability for Zen Desktop and Zen App, respectively. And with that, I'll turn it back over to Martin. Thanks for your time.
Okay, thank you, Nick. So let's move on to mitigations. I would like to start by addressing the thought first. First, what you want to do is that you want to make sure that you are always comparing apples to apples when you hear claims from other vendors about the different performance impact on different products and so on. And as mentioned before, especially with Spectre, you want to be extremely careful. For example, you don't want to see comparison, or you don't want to take seriously comparison of the Zen app on old server 2008 R2 with Horizon running on Windows 10. That's definitely not the case. Also, your experience is going to be very specific to your environment. So even if you see some numbers, you cannot really fully trust them that you are going to see exactly the same impact. What I would also like to mention here is that logging VSI, as Nick mentioned before, is actually giving away some free licenses to measure the impact of Meltdown and Spectre in your environment. So I highly recommend to use them and to understand what's going to be impact for your specific applications. Now, let's talk about different tools and approaches that we have to minimize this impact. Even though we don't really still know 100% the impact of the Spectre, we can assume, and we are making this assumption here, that combined impact of Meltdown and Spectre can result with maybe 20% less single server scalability. And it's also going to impact not only scalability, but it's also going to be the overall responsiveness of the environment, logon times, and many different metrics that can be potentially impacted by this. So, as Nick was explaining before, it's especially for the Meltdown, what you want to do is that you want to minimize the transitions that are being done. And how you can achieve this is you can remove the components or the software that is making these transitions, or maybe you can just reduce the frequency. That really helps. So the first approach that I would like to talk about is simply using Citrix Optimizer, which is official supported tool from Citrix that's removing all the unnecessary components in client or server operating system. Therefore, it's already minimizing the impact of the Meltdown and Spectre because these components are either completely removed or they are just disabled and they are not running. Another mitigation technique that you can do is use Citrix VAM with a smart CPU optimization. It might be able to help you to increase the user density, but even more importantly, it should make your environment more snappy, meaning that you are reducing the impact on the responsiveness and the overall user experience. Next approach that you can take is upgrade and transition, or at least start thinking about it, to Citrix Cloud or to cloud in general, because this enables the scale-out strategy. Even if in the future there is going to be something similar to Meltdown and Spectre, first of all the big cloud providers were the first one to be patched a long time before enterprises could catch up. But also, if you know there's something that's going to reduce your scalability, once you are running in the cloud or once you are implemented the hybrid cloud strategy, this will give you the flexibility to scale out if needed. If you need 10% more servers with cloud, you can just easily implement it right away. Finally, it might be a good idea to just review your environment. Make sure to understand, first of all, what's going to be impact of Meltdown and Spectre. That's number one. And then realize, do you have enough capacity to handle this additional load? For example, can you optimize the logon times? Maybe there is something in your logon process that's going to take twice as long as before and you don't even need it, maybe. Another really good example here, as I was talking about the frequency of transitions, let's say that you have some monitoring that's collecting the data about the disk space. Do you need to run it as frequently as you do? Do you need to run it every 10 seconds, or can you just change the frequency to 60 seconds? But again, your first step should be to simply understand and assess your environment so you will know this is the impact that we are seeing. These are the components that should be prioritized because there is the biggest risk of security breach. And then you can start thinking about how to mitigate and how to solve this problem. Talking about the assessment and understanding your environment, maybe Nick can tell us more about what the Citrix Consulting is offering for our customers.
Sure. Thanks, Martin, again. So yeah, if you've been listening to this and nodding your head and saying, yeah, Nick, Martin, this all sounds good, but kind of struggling with where to begin, that's why our CCS team has put together a formal offering around this to help folks figure it out. And we've actually already been doing this for the last month or so as part of security assessments. So what we would do for a couple of weeks is come in and deploy something like Login VSI, or if you have your own scalability performance testing tool, we can certainly leverage that. But if you don't have anything, we can help you through it and set up something like Login VSI and figure out exactly with your specific applications and your specific workloads, what the performance impact of Meltdown only and then Meltdown and Spectre together might be. And then we can kind of figure out, what makes the most sense in terms of mitigations and how to patch or how to address these issues. So that's kind of what we're talking about here in a nutshell. And if you're interested, of course, just reach out. You can drop a question or reach out to your local Citrix rep, and they'll route you to our CCS team. We can talk about what makes sense for you. And with that, one last slide with a few resources here. The first, of course, Citrix blog. So Martin's actually wrote a pretty good blog with some of this info actually you saw in the webinar up front on Meltdown and Spectre. So that's definitely a resource. You can see the screenshot there on the top right of the the special license. I think Login VSI is calling it an emergency, Meltdown and Spectre license. That is good till the end of this first quarter. So you better grab that in the next week or two if you want to use that. And then the first link there is our security bulletin. Specific to these 3 CVEs, this is kind of where we're making all of our updates. So that 231399 is a good one to bookmark. It's actually been updated, I want to say, 9 times already in the last 2 months. So that's one to bookmark, check back. Some of the testing I mentioned from Login VSI, if you want to look at those Windows 7 and 10 numbers of kind of optimized and unoptimized and see what they did for Meltdown only, I think those tests are really good. Just note that info is from a third party. And then same with Lakeside Testing. I mentioned them on another one of those slides, but didn't get into specifics there. But they also did a really good test I liked, showing some of the the impact of Meltdown only on XenApp. And again, just note that is from a third party and not Citrix. And with that, we'll get into the Q&A in a minute here. But first, I want to turn it back over to Sarah for some closing comments. Thanks.
Great. Thank you to both Nick and Martin. That was an awesome session. Before we move into the Q&A, I'd just like to remind our audience that if you have a question for our speakers, you can submit it in the Ask a Question area on your screen. Simply type your question into the text box and then hit Submit. Okay, while you take a minute to enter your questions, I have a couple of additional tips, if you will. Our friends over in the Citrix Education team are offering all of our TIPS attendees a 10% discount on technical training. All you have to do is visit the bit.ly listed here, bit.ly/citrix.edu, to redeem your 10% discount. And we've listed here a couple of the security-focused offerings that are relevant to today's topic. Also, our next event will be held on Thursday, April 19th, and it's a Citrix on Azure session, which is a follow-up to the session that we hosted earlier this year with architects Kevin Nardone and Jeff Mitchell, who will be attending as well from the Microsoft team. So you certainly don't want to miss that event. Registration will go live shortly at our Citrix Tips URL, which we've listed here. So be sure to check that out next week to register, or you can certainly go there today and subscribe to the series to make sure you're notified once registration is live. And then finally, we're taking the show on the road, so make sure if you are at Synergy, you stop by the Services Showcase in the Solutions Expo. We're bringing together our most popular tip sessions, and we'll have our enterprise architects there on site actually delivering, I believe it's 7 of the sessions that we've delivered across this last year. So you can come, meet the architects, ask them your questions in person, and get an update on some of our most popular content. All right, Nick, I'll go ahead and hand it over to you to get started on our Q&A.
Cool. Thanks, Sarah. So Martin and I are both still on, and we'll now start the live Q&A, as Sarah mentioned. It looks like we have a few good questions that already came in, which is great. But before we begin, I wanted to introduce one more person we have on our live Q&A panel today, and that's Mr. Eric Byers. So Eric's the lead security architect for Worldwide Consulting, and he's been an architect with Citrix for the last 7 years. And he's presented at a lot of conferences, including Synergy, on the topic of security. He's also co-written some of our security white papers. So welcome, Eric. And now let's dive into our first question. I'll sort of divvy up the questions as we go here. And if for some reason we don't get to your question or I accidentally skip it, we'll follow up either directly with you after the webinar, or we'll put together a FAQ and publish it on Citrix blogs. So there's actually a couple questions about the slides. Are they available? Yes, they're available. I think if you just go to the, if you're in the webinar right now, if you go to Event Resources and kind of expand that, there's actually a link to the PDF, so you can just grab them right there. So that covers the first couple questions. On to the next one. I've applied some of the patches and haven't seen much of a performance difference. Do I need to install all of the patches? Eric, do you want to take that one?
Sure. Yeah, this created a lot of confusion early on. It is common to install all the patches, have a false sense of security or a false sense of performance, since even with all the patches installed, missing firmware dependencies, missing registry settings, the patch won't be effective. So in January and February 2018 patches, it required a registry setting to be set by the antivirus, which was later listed in the 2018 release of the March release. Microsoft provided some nice tools, so they created a tool called Speculation Control, as well as Gibson Research also created a good tool called Inspector to help determine if the patches are actually enabled and effective. So those are some useful tips.
Cool, yeah. I know internally we've been using that Speculation Control. It's kind of nice, makes things black or white. Thanks, Eric. So next question, what about the newly discovered AMD vulnerabilities? Are they different variants of Meltdown and Spectre? Martin, you want to grab that one?
Yeah, I can definitely take that one. So, no, the AMD vulnerabilities are not new variants of the Meltdown and Spectre. They are not using the speculative execution. So that's not this new class of vulnerabilities. They are just normal vulnerabilities that are found in the hardware. The reason why we are seeing them now is that with the reveal of Meltdown and Spectre, security researchers are starting focusing a lot more on the hardware. We just saw the brand scope that was announced, found a couple of days and so on. Microsoft and Intel announced bounty programs, which is about $250,000 if you can find another speculative execution bug. So we can definitely expect more vulnerabilities discovered in the hardware in upcoming months, but these AMD vulnerabilities are not speculative execution related.
Okay, thanks, Martin. Next question here, how will the new Fallout vulnerability affect scalability? Eric, do you want to tackle that one?
Sure, yeah. So this new vulnerability is similar to, it's the AMD vulnerability. It only affects AMD. It does require a firmware patch, and that's really where the similarities end. Although this is a kind of update, it might sound similar to Spectre Meltdown or Mitigation. AMD has communicated the patch should not have a performance impact. So really not all security fixes have a significant performance impact, but there are often small amounts of overhead for additional bounds checking, validation of input that occurs. This brings up a good point, though. There are really a lot of software updates and patches that are applied to systems every month, and some of these may have a negligible effect, while others might have a small impact, but many small impacts will become an aggregated larger impact. So this underlines why we need more mature application and platform onboarding processes overall and more thorough testing. Microsoft released security patches to address, something like 50 vulnerabilities in the monthly update last month, along with several applications receiving updates. There will be some impact on performance and environment density on a monthly basis, either positive or negative. We're creating a risk, really, to the stability and the performance of the platform anytime we make an untested change. So that's really why we're underlining, we need to start testing a lot more on a monthly basis going forward.
Cool, thanks, Eric. And that was actually another one. I think you covered a couple of the questions. There was another question about, starting to apply some of the patches. Are you seeing performance, impact on some of the monthly updates and whatnot? And I think overall, it's, if you've applied all the mitigations, it's probably, I guess, as bad as it's going to get, as worse it's going to get, probably right now. And then I think over time, and over this year, as we kind of, find optimizations, things will improve. So, next question. I heard you mention KPTI when talking about Meltdown, but isn't that a Linux thing? Is the mitigation the same on the Windows side, or is it different? Let me take that one, actually. I was talking about that. And that's a good question, because I think I failed to mention the specific name of how the Meltdown mitigation is implemented on the Windows side of the house. It's actually called kernel virtual address shadowing, or KVA shadow, I think for short. And at a high level, KVA shadow, it's very similar to how KPTI works in the Linux world, essentially dual page tables, as I described earlier, and we isolate PTEs. And both implementations are largely based on the initial Kaiser work, if you're familiar with that. But on the Windows side, KVA shadow gets its name from the fact that when we separate out the PTEs in the user and kernel spaces, the user space is kind of special, and it's a shadow user address space. If you remember from earlier in the presentation, that user space maps the entire user memory contents of a process, but only a minimal set of kernel mode transition code and data pages needed to switch into and out of the kernel address space. So the select set of privileged kernel code and data transition pages handling the details of those switches, those are shadowed into the user address space, and they're considered safe in that they don't contain any privileged data that would be harmful to the system if it was disclosed to a untrusted user mode app. So that's why it's called KVA Shadow on the Windows side of the house. And while it's the same idea in theory as KPTI, the implementation is certainly different under the hood, on the Windows. So great question. Next question here, is there any specialized template available for Citrix Optimizer? Or are you planning to release new templates? Martin, I know that is right up your alley. You want to grab that one?
Yeah, that's the one for me, definitely. So we don't have any specialized templates for Meltdown and Spectre today, and they are actually not really needed. So you just use one of the existing templates based on your operating system. Now, what we are doing is that we started doing some internal testing to determine the impact of Optimizer and different tweaks and tuning. So if these tests show some added value, we might decide to release actually specialized templates that will be designed to minimize the impact of Meltdown and Spectre, but this is still to be discussed. We are just running the tests at the moment. So just use the templates that you have. They should be fully functional and working without any problems already.
Great. Thanks, Martin. Next question. Eric, let's see if you can grab this one. I have AMD processors. Am I affected?
It's sort of similar to earlier questions. AMD has made some statements, right? So they believe that they are not susceptible to Meltdown due to their privilege level instructions, but they are vulnerable to Spectre Variant 1 and Variant 2.
Yep, thanks. In that service offering that was mentioned at the end, how are you going to measure the impact of Meltdown and Spectre? And there was another question about login VSI here too, so maybe I'll try to tackle both of those at once. So I discussed this, a few minutes back, but I probably didn't do it proper justice. So if you have a current, performance and scalability testing tool, we can certainly use that. But if you don't, we typically use login VSI these days, and we'd even set that up for you as part of the engagement. And then we'd look at patched versus unpatched systems with the various combinations of variants to see how performance is impacted by each. And that's actually exactly what we're doing internally, in Citrix engineering right now. And so in terms of what we look at not only the VSI max score, and if you're not familiar, that's just a measure of single server scalability in the login VSI world. But we'd also look at things like application response times and login times. There was another question in here I'm seeing in the Q&A about login times. And yeah, we're seeing both of those latter items inch up when the mitigations are applied in our own lab. So we can't just focus on triple S or scalability. We look at everything as part of that engagement. And then at the end of the engagement, I think the idea is you'd have a really good understanding of how each variant impacts your unique environment performance. But you'd also, the bonus, right, is you'd have a test harness for future testing. So when optimized patches or additional vulnerabilities are discovered, let's say, you can jump on it and basically test almost immediately. So that's kind of the idea of that 2-week engagement. And a couple people have questions about, how do I get more info on that? We can reach out to you directly. Next question, should all systems be updated? There's a loaded one. Eric, do you want to take that one?
Yeah, it's a loaded question. I think the statement should be yes, all systems should be patched. We can never really say a system shouldn't be patched if there is a known vulnerability, but there may be some systems that are running with only IT deployed binaries, so trusted binaries and trusted processes with complete lockdown of processes by trusted users, and your security team may determine the risk is low and patch accordingly. But that's really the exception to the rule, right? We want to encourage all customers to meet with their respective security teams and their business owners and evaluate the risk of each vulnerability and determine a plan of mitigation in a specific order of mitigation of those things. That's part of a normal, healthy security remediation process.
Awesome. Thanks, Eric. Well, it looks like that may be it on the Q&A front. I know I tried to combine a couple, so again, if I happen to miss your question, we'll follow up either directly with you, since we do have, I think, your email addresses, it looks like. And then we'll put together, if there's let's say we missed 5 or 10 questions, we'll put together an FAQ and publish it on Citrix Community if there's a lot of them. But I think since there's only a couple, we can probably follow up directly with folks. Anyways, thanks for tuning in, and we really appreciate your time today. Talk to you later. Bye.